All right, during this screencast, we are going to talk about the surface of the Earth and how it's divided up into plates and how those plates interact. And I don't know why I went with this image here. I can only imagine that someday I'll be the old man and my one of my daughters will maybe come into the kitchen upset with me and start smashing all my plates. Anyway, moving on. So the lithosphere of our planet is divided into plates, and these plates are constantly moving. There's seven main plates, and there's a lot of little small plates, and I'm not going to go over every one. I will talk about some key ones that as we go through this. Each one is made of either continental or oceanic crust, or some of each. The area where the plates meet are called the plate boundaries, and they fit together like an Earth jigsaw puzzle. The plates move very slowly over the asthenosphere. Remember, the asthenosphere is that molten part of the mantle that we just talked about. Typically, they move at about 1.5 inches per year. They move towards each other. They move apart from each other. They shift sideways. The Earth that we're seeing right now in this GIF here is it hasn't looked like this for about 201.3 million years. So we're seeing kind of Pangea breaking up here, and some of the mountain ranges that we're going to talk about today were formed back when the Earth looked like this. Because all the plates fit together, movement of one plate affects the others around it. The study of the movement of these plates is called plate tectonics. So the movement of these plates cause new features on our Earth. It's constantly causing the formation of new features on the Earth's surface. Where plates move apart below the ocean, magma from the mantle will well up in between those plates along the boundary. It'll cool and it'll harden and it'll form a mountain range or ridge of new crust. As the movement continues and more magma wells up in the center, the ridge spreads out sideways, becoming a spreading ridge. Boundaries where new crust is formed are called constructive boundaries. Now, an example of this is the Mid Atlantic Ridge. It's where the North American plate, the plate that we're on, is moving away from the Eurasian plate, the plate where Europe and Asia is on. It's created the longest mountain range on Earth. Okay, the Mid Atlantic Ridge is the longest mountain range on Earth, but unfortunately, most of it is below the Atlantic Ocean, so you can't see it. There are some spots that are poking up, and they're great places to see volcanic activity. One of these places is Iceland. Okay, you guys have all heard of Iceland. Another is farther south in the Atlantic called Ascension Island. You may not have heard of Ascension Island, but I have some pictures here. So this is Iceland. It's a great like tourist destination. People go there to go in the hot springs that are fueled by this volcanic activity. The other one is Ascension Island, which is a British colony. Actually, it was a British colony, and there is like nothing there. There's nothing there, and it's really got this uh, otherworldly kind of landscape. These red mountains and just volcanic rocks everywhere, and it's hot and steamy, and it's no place you would want to go for a vacation. All right, the next thing I want to talk about are where plates come together. This is called a destructive boundary. A destructive boundary occurs, or subduction zone occurs, where an oceanic plate or a continental plate move together. The heavier oceanic plate moves beneath the lighter continental plate. Remember, we talked about rock densities in our last Ed puzzle? Uh, so, that oceanic plate's made of denser rock, so it goes underneath the continental plate. And it forms a trench where they meet. And as the plate sinks, it becomes molten, forming new magma. So what we get are these spots where one plate goes under another and magma wells up. The Ring of Fire is a great example of this of a subduction zone. The Pacific plate is more dense than the surrounding plates, so the interaction around the plate's boundary are responsible for much of the volcanic and seismic activity on our planet. And you could see it's literally it's all around the continents, this area where this Pacific plate is diving under the other plates, and this is where we get our earthquakes and stuff like that. Um, okay, where two plates push together above ground, which happens too, the crust ends up buckling and folds upwards, and it forms high mountain ranges called fold mountains. And the Earth's crust is thickest at these points. So we can see here in this animation that these two plates are pushing against each other, and this whole mountain range is being formed. And the highest mountains on the planet are formed by these fold belt mountains. And we have new and old fold belt mountains. We have the Himalayas, which are super tall mountains that they're being caused right now. They're being pushed up because the Indian and Eurasian plate are slamming into each other, creating these fold belt mountains. We also have the Andes Mountains down in South America, where the Nazca and the South American plate are smashing into each other and forming that mountain range, and that's the longest mountain range above ground on our planet. Now we have old fold belt mountains too, and these are went back when kind of Pangea was forming. So the Appalachian Mountain Range, which is the closest mountain range to us, was caused by the American and African plates when they collided. These mountains at one time were the highest in the world, and they were higher than current day Mount Everest. So these mountains were gigantic. What happened? What happened was 200 million years of weathering and erosion, and it's decreased their size quite a bit. The Ural Mountain Range was created when the Baltica and North American plate collided. These mountains were formed when the supercontinent Pangaea was created, when all the continents came together as Pangaea. A full belt mountain range occurred here, and that's where these Ural Mountains came from. So super old. The last thing I wanted to talk about was just kind of a bonus review. I know you guys have seen this before, but it bears repeating. We have three different rock types on our planet, right? The rocks that make up the Earth's surface, uh, well, the rocks that make up the Earth's surface is constantly being added to. It can be divided into three basic rock types: the igneous rocks, sedimentary, and metamorphic rocks. Now, igneous rocks are formed from volcanoes when molten rock cools and becomes solid. So, well, I say volcanoes, but it's formed from molten rock. This can happen inside or on the surface of the earth. So, rocks that are formed within the earth, they cool slower, they have time to grow a lot of crystals in them. Those are called intrusive igneous rocks. All right, and our examples are basalt, andesite, granite, and dorite. Extrusive igneous rocks make it to the surface of the Earth, and they cool much more rapidly. And these are our obsidians and our things like pumice. So two types of igneous rocks, but they all come from cooling magma. Okay, sedimentary rock is formed when sediments, such as rock particles, are deposited by water or by weather. They're buried and then squashed into layers called strata. And we can see the different rock layers here. This is strata, and this is a sedimentary rock. You can see the strata in it. This is Delicate Arch in Arches National Park in southern Utah, and you can see where this is just become a victim of wind erosion. The wind whips through here and carries little bits of sand, and it wears down on this rock. And this thing probably won't be around all that much longer because you could see it's called Delicate Arch because of this little delicate piece here where it's going to fall down. But it's a very cool spot to get to, and it takes about a half a day to hike up to it. Anyway, And our last type is metamorphic rocks. So when a rock type is changed by intense heat and pressure from the earth, a metamorphic rock is formed. Okay, so if a rock is down in the earth for a long time and gets a lot of heat and pressure, it goes through a change. Like shale will turn into schist when it's put under heat and pressure. And this is a picture of schist right here. Limestone will turn into marble when it gets put under heat and pressure, and quartz sandstone will turn into quartzite, which is what we're looking at here. All right, so I know I'm kind of dragging on here, and this is taking a while, but just the important points here. Number one, the surface of our Earth is divided into plates. Number two, these plates move around on liquid magma and interact with each other at their boundaries. Number three, when plates move apart, the magma wells up to create and create a ridge. The example that I gave was the Mid-Atlantic Ridge in the middle of the Atlantic Ocean. When plates move together, they can create subduction zones. This is when one plate moves under another. This creates a trench where volcanic activity is common. The example I gave was the Ring of Fire in the Pacific. When plates move together, they can also create fold mountains. The example I gave was the Himalayan mountains, the Ural mountains, the Appalachian mountains. And finally, there are three types of rock. Igneous, formed by magma, can be extrusive or intrusive. Sedimentary rocks formed by little pieces of rock sediment being pressed together. And finally, metamorphic rock, where any type of rock is put under heat and pressure from the earth, it can form a metamorphic rock. Thank you.